Hello everyone, my name is Kiran Kumar Ravindran. I'm going to present my project that I did for the course Machine Learning, namely classification of vehicle types using convolutional neural networks. So before going into the project, I want to give an introduction about what is machine learning. Machine learning is a process by which the systems learn with experience to increase their performance. The same has been stated by Tom Mitchell, where he says that machine learning is the study of algorithms that improve their performance at some task with experience. So in this slide, I have differentiated the traditional programming and the machine learning. The difference between traditional programming and machine learning is that in traditional programming, input data will be programmed to get an output. So in machine learning, both the input and the output data will be defined so that the computer system will program according to the data input and output. This is the most important part of our project, convolutional neural networks. Convolutional neural network is a deep learning algorithm used in machine learning peripherals for pre-processing of images in order to make machine learn images upon visualization for solving image classification and detection problems. In biological terms, CNN's design is simply based on the main visual cortex of human brain, which is responsible for processing visual information. Hence, the system that employs CNN algorithm will be capable of learning very abstract traits for accurately identifying things. In this slide, I have presented a simpler illustration of convolutional neural network based on our context. In this, the vehicle image will act as input and this will be fed into the hidden layers where convolutional with max pooling layers along with the ReLU activation function will do some image processing which makes the vehicle image input into a 3D output tensor, and this 3D output tensor from the final max pooling layer will be fed into the flattened layers that unrolls the 3D output tensors into a one-dimensional input tensor, since fully connected layer that is responsible for making classification accepts only one-dimensional inputs. In the final fully connected layer with the softmax activation function, there happens the vehicle image prediction where the input image given will be predicted whether it is a car or a truck or a van or a bicycle. Moving forward, I have the problem definition in this slide. Image classification in machine learning is a supervised learning problem in which we will be predicting the type or class of object using pre-processed datasets or photographs. In supervised learning, both the image input along with the class of an image will be known by the CNN model in training, whereas in unsupervised learning, only the image will be given, the class of the image will not be given. For training the CNN model, I've used the vehicle recognition dataset from Kaggle website, which consists of 8,582 images from 5 different classes of vehicles, namely bicycle, bus, car, motorcycle and van. For classification purpose, I have used a test dataset that consists of 1810 images from the same 5 different classes of vehicles that has been used for training the CNN model. So the motivation behind my project is to achieve an accuracy of more than 75% on classification of vehicle and to study which activation and optimizer function in combination performs the best for image classification problem. In practical application, I want to use this project to reduce traffic congestion in roads through effective operation of traffic signals by smart monitoring with AI sensors. Apart from CNN model implementation, I have also done data augmentation in my project, which is a very important part. In data augmentation, the image input will be increased by adding slightly modified copies of the already fed input images, and this data augmentation will help reduce overfitting when training a machine learning model, hence increases the accuracy of the machine learning model, but at the cost of increased time of model implementation. The data augmentations techniques that I have used in this project are scaling, rotation, affine transformation, and flipping. In making this, the image will learn whether the input image is a car or a van or a bicycle, even if it is blurred or rotated 180 degree or 90 degree, or it is flipped to horizontal side or to the vertical side, or it is transformed from one shape to another shape. Irrespective of all these cases, the machine learning model will learn whether the given vehicle image is a car or a bicycle or a van according to the vehicle image inputs. So this is the CNN model implemented in my own computer system. This model implementation takes around 5 to 6 hours. After that, training with SGD optimizer has been done, where an accuracy of 67.5% has been achieved on training with SGD optimizer, and the same has been done with Adam optimizer, where nearly 62% accuracy has been achieved, which is comparatively less compared to the SGD optimizer function. So these are some of the examples of classified images that I have presented for you, for letting you know that I have done achieving classifying the images. The first image is a bicycle that has been correctly classified, and the following images are car and van, which is also classified properly. So here are some of the examples of misclassified images. The first one is actually a van that has been classified into car. The next one is the vice versa, where a car has been classified into van. So what can be the reasons for image misclassification? The few reasons that might cause the CNN model to misclassify in this context will be blurred, cropped, or transformed bicycle image will resemble like a motorcycle to the computer system, or vice versa. Or a van is blurred, cropped, or transformed in a way that it resembles a car, or same vice versa, so that the computer system views a car or a van into a van or a car. And these are the two reasons that I observed while doing my project. And finally, the accuracy obtained on classification of vehicle types is 77.5%, and one of my aim is to achieve 75% accuracy, and this has been achieved on classification. And the total number of misclassified image for reference, for your reference, is also being presented here, where the total number of image misclassified are 407 out of 1810 images. Apart from the accuracy part, I have identified ReLU activation function in convolutional layer with the softmax activation function in the final fully connected layer with the SGD optimizer functions the best compared to the other combinations. In the above combination of activation functions and optimizer function, I have achieved the best train, validation and test accuracies. Both the CNN model and image classification accuracies can further be improved, which is a possible future work with the use of supercomputers where the time taken for training the CNN model with increased CNN model complexity won't be an issue that need to be considered. Finally, the possible practical application of this project is traffic flow control. The AI sensors which are capable of giving vehicle data need to be programmed in a similar way to predict the class of vehicles and the number of vehicles present in a road. These AI sensors need to be integrated with systems that control traffic lights so that smart functioning of traffic lights can be established. So that's it for the presentation. All your feedbacks will be greatly welcomed. Thank you.